evaluating. Can anybody give me a definition for that word? When you see the word evaluate, what does it mean? Solve, okay. I like to think of figure out.
I was gonna say, and I was gonna say that.
All right, now most of the time, if not all of the time, when you evaluate something, your answer is going to be a number. Now, we've been solving equations lately, but when you evaluate something, a lot of times you're plugging something in. So there is no equation necessarily as much as you're just plugging a value in. Now, let's talk about what the word linear means. First of all, if you graph a linear equation, it's going to be a line. That's why it's called linear. Now, how do you know what a linear equation is if you don't have the graph? Well, if you look at the variables, they're basically not going to have any exponents, okay? There are actually exponents there that you can't see. The exponent is 1. So technically, a linear expression is any variable where the exponents are not bigger than 1. I'm going to give you a list of linear expressions just so you're not too confused. All right, so first example, 3x is a linear expression. The x doesn't have an exponent. In fact, it's 1 if we want to fill it in. If you were to graph it, it would be a straight line. All right, let's do another one. How about 4x plus 2? That's also a linear expression. The exponent is 1, it's not 2. That's a quadratic if the exponent is 2. There are two different terms here, but there are no x squareds or x to the third or anything like that. So it's also going to be a straight line. You could have negative 1/2. Let's use a different variable, m. All right, so even though the coefficient here is a fraction, it doesn't matter. Because again, this doesn't have an exponent. So if you were to graph this, it'd be a straight line. Or we could do, how about 2.7 n minus 4 over 3. Believe it or not, if you graph that, that would also be a straight line. Okay, the variable does not have an exponent. Really, that's all you're looking for. I mean, the 2.7 is going to change the graph, but still going to be a straight line. Actually, I graphed it wrong. It would go that direction, but anyway, you get the point. And then the minus 4/3 just has to do with something else, which we'll talk about later, which is called the y-intercept. All right, so example 1. Let's say we have 2x plus 3. We want to evaluate 2x plus 3 when x equals negative 1. So the first thing you're going to do is, okay, if x equals negative 1, that means I can plug in a negative 1 right there for that expression. So I'm going to rewrite the expression. And every time you plug something in math, put it in parentheses. It's going to save you a lot of trouble, save you a lot of mistakes. So first step is to plug in the value of the variable. In this case, it's negative 1. And then the next step is to simplify. So would you multiply or add first?
Multiply.
Multiply, and you get?
-2.
-2 plus 3. Okay, good. That's it for that example. Yep, so the reason I'm just doing this today is because tomorrow we'll look at, well, not tomorrow, probably Monday, we'll look at another variable y. And that's all we're actually doing is solving for y today, even though we're not actually going to technically be using y. I want to get you guys comfortable with linear equations and slope and y-intercept and all that kind of stuff. All right, next one. Evaluate 3 minus 1/2 n when n Let's see if I can move it down a little bit. When n is equal to -10. So again, whenever you plug a number in, plug it into parentheses. You'll save yourself a lot of trouble. And that's what I'm going to do for this one. Normally I rewrite my expression and then I will plug in. So notice, if n is -10, since there's an n there, I'm going to put it in parentheses and put -10. All right, so
Negative n be positive 10?
negative n would be positive 10. Yes, that's right. Good job. Negative n would be positive 10. All right, so now that we've plugged it in, we're going to simplify. We need to multiply before we subtract. What is that going to become? 3 minus 1/2 times -10.
3 minus -5.
Yeah. 1/2 times -10 is -5. So we just multiplied, right? Multiply the 1/2 times the -10. Now we will subtract. But we are subtracting a negative. So therefore it becomes 3 plus 5, which is 8. Great. In case you guys forgot, here's your order of operations. P stands for parentheses. E stands for exponent. I'll just put an exponent up there. Could be 3 or 4 or whatever. M stands for multiply. D stands for divide. A stands for add. So make sure you do it in that order, which is what we're doing. We multiplied first before we added. Don't forget to do that. All right, next one. Evaluate. Let's see here. Let's try y over 7 minus 5. When y equals 91. Okay, so we're going to write out the expression y over 7 minus 5. What do you have? What are you going to do? What's the first thing you're going to do?
Rewrite. Divide 7 by 91. Rewrite it. Well, 91 by 7.
All right, we're going to plug in y, 91 for y. Put in parentheses.
Equal 23.
Well, what is, so first of all, PEMDAS, we will divide before we subtract. What is 91 over 7? You guys remember? 13, yes. 13 minus 5 equals 8. Another thing I didn't talk about with linear equations is the variable can't be in the denominator. So if it was 7 over y, it actually wouldn't be in a linear expression. That's actually called a rational expression. All right, T, something you might, anybody in physics? Yeah, T stands for time, and you use it a lot in physics. It's a common variable. All right, let's do something a little bit more involved here. Evaluate -5 times 6 minus t plus 4. And we're going to make t a decimal. 2.5 seconds, for example. Now, this is still a linear expression. Doesn't have an exponent of 2 or anything. It's not in the denominator. So first we're going to plug it in for the variable. In this case, we're plugging in 2.5 for t.
3 plus 12.5.
Well, we'll talk about that. You can do it that way. You were multiplying first, but remember, with PEMDAS, what's the first thing you need to check for?
Parentheses.
Yeah, so actually, even though you can distribute first, you might as well do what's in those parentheses first. So 6 minus 2.5 is close to 4.5.
Negative
3.5. Yeah, I know it looks like 4.5 because it's 6 minus 2, right? But then you have to subtract 0.5 from that. That's going to give you 3.5. All right, next, would you multiply or add? Multiply. Negative 5 times 3.5.
16.5 or 16.
Good job. Negative 16.5. Okay, 5 times 3 is 15 plus, oh, wait a minute, 17.5. Yeah, I had to rethink that. 5 times 3 is 15, and 5 times 0.5 is 2.5. Put those together, you get 17.5, and then bring the negative down. Then we're going to add 4 to that. Final answer, once we add, would be what? So if it was negative 17.5 minus 4, it would be negative 21.5. But I haven't heard the right answer yet. I've heard everything. Okay, I've heard everything. Yes, negative 13.5. All right. Remember, you're moving closer to 0 on the number line, so when you add a positive to a negative number, the answer should be closer to 0. Okay, one more. We're going to use the variable p. Don't ask me what that stands for. I don't know. Prime number. I don't know. All right, evaluate 1/4 p minus p when p is equal to 2/3. Again, this is a linear equation, even though it looks a little weird. You can actually simplify that before you plug it in, but you don't have to. We'll just follow the steps. All right, so we're gonna, wherever there's a p, so we got 2 p's this time. So the point for this one is whenever you have 2, you have to plug in both times. So we're going to plug in 2/3 there for p, for that p, and we're going to plug in 2/3 for the other p, putting them in parentheses. Does anybody remember how to multiply two fractions? Multiply across, right? 1 times 2 is 2. 4 times 3 is 12. Okay, we'll simplify that in a second. The second one is just minus 2/3. Actually, we don't need to simplify it because in order to add or subtract two fractions, you have to have a common what? Common denominator.
Wouldn't it be easier to simplify it?
I guess it would be, yeah. We can do it a lot of different ways. We could write it as 1/6. Is that fine? Okay, so we agree that 2 over 12 is the same as 1/6. All right, what would be the common denominator of those two? It'd be 6. So we now multiply the second one by 2 over 2. We have 1/6 minus, multiply the top there, would be 4/6. Final answer. Remember, when you add or subtract fractions, you only do the top. The bottom stays the same.
1/2. No.
Okay, good. So 1 minus 4 is -3, and then that reduces to -1/2.